When you're doing a number of random experiment or tossing a coin, you have to fix the number of trials. When it is not a swimmer, they have given the failure value. That means they have given Q is equal to 1 by 5. In Bernoulli's trials or in events, we does not take the outcome of an event here. We either consider our event as success or failure. Hello everyone, a warm welcome to one and all. This is Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Here in this session, we are going to study a very interesting concept in probability, that is Bernoulli trials and binomial distribution. As in case we have studied what is probability distribution, how to find out the mean, variance and standard deviation of probability distribution of a corresponding random variable x. So now here we are learning about Bernoulli's trials. So what are these Bernoulli trials? So trials of a random experiments are called Bernoulli trials if they satisfy the following condition. So what are the conditions? The first one, there should be a finite number of trials. That means when you are doing a number of random experiment or tossing a coin, you have to fix the number of trials. Next, the trial should be independent. So we know that independent events. What do you mean by independent events? So an event which does not affect the occurrence of the other event is nothing but independent events. So the occurrence of one trial must not affect the event happening in the next trial. Each trial has exactly two outcomes, success or failure. So here in Bernoulli's trials or in events, we does not take the outcome of an event here. We either consider our event as success or failure. So thus we have only two outcomes in Bernoulli trials. The probability of success remains the same in each trial. So when we are fixing the number of trials of a random experiment, the number of success or whatever the outcomes we have here, only two outcomes, one is success and one is failure. So every time when you are going to trial an event here, so the number of success rate or the value of the probability of a success will be the same throughout how many trials you have done. So now these conditions, when it's satisfied, they are called as Bernoulli trials. Now let's take an example here. 6 balls are drawn successively from an urn containing 7 red and 9 black balls. Tell whether or not the trials of drawing balls are Bernoulli trials when after each drawn, the ball drawn is replaced or not replaced in the urn. So here 6 balls are drawn successively means the total number of balls here is 7 plus 9, which is 16 balls. When I say what is the probability of drawing a red ball from an urn? Obviously, it will be 7 by 15. So a red ball is drawn now. Then the ball is replaced back to the urn again. Again, what is the probability of drawing a red ball? It will remain same, that is 7 by 15. So each time when you take out a ball from an urn and if you replace it back, the value of the probability of a red ball will remain the same. Hence, we can call the trials as Bernoulli trials. So hence, with replacement, when you are going to calculate the probability value of a trials, it remains same. Hence, we can call them as a Bernoulli trials. Now, in the second condition, not replaced in the urn. That means once a red ball is taken out from the urn, we are left with only 14 balls now. Now, at first trial, the probability of drawing the red ball is 7 by 15. Now, the second trial comes where we have not replaced back the first red ball. So, remaining red ball is 6 and remaining total ball is 50. And it goes on decreasing. That means in each trial, the value of the probability goes on changing. But for a Bernoulli trials, the probability of success must remain same in each trial. Hence, the second case here, we can't say them as Bernoulli trial. Hence, To say the trials or Bernoulli trials, the following condition has to be satisfied. That is, the probability of success rate of getting, which we have taken as an example, getting red must be 7 by 15. How many times you make a trial, and that is independent towards the next trial, and every time we get a success of getting a red ball as 7 by 15, and there should be finite number of trial, means we have to fix a number of trials for particular number, say 10 times, 50 times, 100 times. So that means the number of trials must be finite here. So as I say about Bernoulli trials, so we have only two outcomes, that is, it is success or failure. So when I talk about the success, we have failure also. When you have 50% of chance of getting success, then we have 50% of chance of getting failure. Or when the success rate is 1 by 4, the failure rate is 3 by 4. We can clearly say P as a success rate and Q as a failure rate here. So we can also call Q as 1 minus P, because they are complement to each other. So whatever the value for the success rate you will get, it is exactly complement to the failure rate. So if you get it as 1 by 4, it will be 3 by 4. If it is exactly half, then the failure rate is also 1 by 2. So hence we denote the success rate by small p and the failure rate by Q. And the binomial distribution is nothing but calculate the probability of a success. So that is given by P of x is equal to x. Again here x represents the random variable. So for which value we are going to calculate the success rate of the probability. So thus, and it is denoted by P of x, and it is defined by P of x is equal to NCx q to the power n minus x, p power x. X can take any values from 0 to n, and the value of key, as I said, it is 1 minus p. So this p of x is called as the probability function of the binomial distribution. Now why it is called as binomial distribution? Because we are distributing the binomial of n Bernoulli trials and calculating the probability of success rate with number of trials as p, and it is denoted by b n comma p, where n denotes the number of Bernoulli trials and it is finite. P represents the success in each trials, and Q can be calculated as a complement of P, that is 1 minus P. Let us take few problems. And for your examination purpose, there will be one question on Bernoulli trials or binomial distribution for 5 marks in your examination. So it's a compulsory question. So we can get one question on binomial distribution in your examination. First question, a person buys a lottery ticket in 50 lotteries, in each of which his chance of winning a prize is 1 by 100. What is the probability that he will win a prize exactly once? So we need to calculate what is the probability that he will win a prize exactly once. So here they have given the number of Bernoulli trials, that is, it denotes 50 lotteries. That means he has taken lottery 50 times. Hence the value of n I can take is 50. And the success rate is given, that is means chance of winning is given, that is small p, whose value is 1 by 100. Once P is given, you can calculate Q, that is 1 minus 1 by 100. Hence, we can write Q as 99 by 100. Now, let us express this in terms of binomial distribution formula. That is, probability of x is equal to small x, which is equal to NCx q to the power n minus x p to the power x. So now replace each and every value. They have asked you what is the probability that he will win a prize exactly once. Exactly once means the value of x will be equal to 1. Hence p is equal to x is equal to 1, which is nothing but exactly 1. So what are the value we have here? N is 50, 50 C1. Value of Q is 99 by 100 whole to the power n is here 50 minus 1. And p here we have 1 by 100 whole to the power 1. Now what is the value of 50C1? It is 50. So therefore probability of winning exactly once is 50 into 99 to the power 49 whole divided by, clearly in the denominator we have 50 minus 1 means 49, and again 1 times 100 it becomes 100 to the power 50. So this will be the probability value of a person winning the lottery exactly once. Now here, what is 50C1 we will get? We will get probability of x is equal to 1 is equal to 50 into 99 by 100 whole to the power 49 into 1 by 100. And when you cancel it, you will get the value as 1 by 2 into 99 over 100 to the power 49. Hence, this is the probability value of the man winning a lottery exactly once. Next, if a fair coin is tossed 10 times, find the probability of exactly 6 heads and at least 6 heads. So, the number of trials is n is equal to 10. Now, what is the success I need to take here? Getting 6 heads is the success and not getting 6 heads will be the failure. Then what is the probability of getting 6 heads? So it is exactly same as not getting 6 heads. So therefore the value of P will be 1 by 2 and the value of Q is also 1 by 2. Now let us calculate the probability of the success rate for the value x, that is NCX Q to the power n minus x p to the power x. So probability of x is equal to x is equal to n is 10cx, q is 1 by 2, 10 minus x, p is 1 by 2 x. Now the first one they say exactly 6 heads. That means x is equal to 6. So exactly 6 heads means we will get 6 heads. So therefore it is 10c6, 1 by 2, 10 minus 6, 1 by 2 and here we have 6. So when you calculate this 10c6 here, probability of getting exactly 6 heads is, so 10c6 can be written as 10 into 9 into 8 into 7. 6 factorial will get cancelled. So we are left with 4 into 3 into 2 into 1. And here we have half 4 times, half 6 times. So therefore we can write it as 1 by 2 10 times. And when you solve this, you will get the value as 105 divided by 512. So this will be the probability of getting exactly 6 heads. Now my second question is, I should get at least 6 heads. So that is the minimum 6 heads. Hence I can represent this as probability of getting at least 6 heads. That means minimum I can get 6. So maximum I can get 10 heads because I have done 10 trials here. So therefore here the outcome will be probability of x is equal to 6, probability of x is equal to 7 plus probability of x is equal to 8 plus probability of x is equal to 9 plus probability of x is equal to 10. Now each time when you calculate here, so we have here probability of x is equal to 6 as 10 factorial by 10 minus 6. So that is every time you should use the same formula 10c6. So 10 factorial, 10 minus 6 factorial. So that is 6 factorial. And here it is 1 and the same here. Each time we will get here 1 by 2 whole power 10. Plus here you have 10 by 7 factorial, 3 factorial, 1 by 2 power 10. Plus here we have 10 factorial divided by 8 factorial, 2 factorial, again 1 by 2 whole power 10. Next we have 10C9. 10C9 can be taken as 10. And again we have here 1 by 2 whole power 10. Next we have 10C10. 10C10 is nothing but 1. 1 into 1 by 2. 10 minus 10, 0. 1 by 2 whole power 10. Again we'll get 1 by 2 whole power 10. Hence we can take 1 by 2 whole power 10 as a common factor and evaluating the factorials here and adding all the values, we will get the answer as 193 divided by 512. So this will be the value of getting at least 6 sets. We can also calculate value of getting at most 6 sets. That will be x less than or equal to 6. That means you should take probability of value of x is equal to 1, 2, 3, 4, 5 and 6. Find each binomial distribution value, add the probability. You will get the value of at most 6 heads. Next question. A die is thrown 6 times. If getting an odd number is a success, what is the probability of getting 5 success? At least 5 success and at most 5 successes here. So when I say 5 success, here exactly x is equal to 5. At least means I can take x is equal to 5 and x is equal to 6 because the number of trials is 6. And at most 5 success means we need to take x is equal to 1 to 5. Instead of that, I can take 1 minus probability of x is equal to 6. So when you subtract this value from 1, you will get the total value of all the binomial distribution of a random variable x is equal to 1 to x is equal to 5. Now here we have n is equal to 6. And getting an odd number means p will be 1 by 2. So when a die is thrown, getting an odd number is 3 by 6, which is 1 by 2. And getting an even number is a failure. So that is also 1 by 2. Hence binomial distribution, probability x is equal to x can be written as ncx q to the power n minus x p to the power x. Now substituting here for the first one, we need 5 success. So therefore here 6c5, 1 by 2, 6 minus 5, 1 by 2, 5. 6c5 is 6, 1 by 2, whole power 6 we will get. So we will get the value as 6 into 1 by 64. When you cancel it, so we will get probability of getting at least 5 successes is 3 divided by 32. Next, I need to calculate the probability of at least 5 success. At least means x greater than or equal to 5. Hence, I can take value of x is equal to 5 plus value of x is equal to 6. So, value of x is equal to 5 is already calculated here. It is 3 by 32. And value of x is equal to 6. If you apply, you will get 6c6 as 1. 1 by 2, 6 minus 6 will become 0. 1 by 2 to the power 6 is again here 1 divided by 64. And when you take the LCM and solve it, you will get the value as 7 divided by 64. The third question is we need to find out at most 5 success. At most means probability of x less than or equal to 5. So that means here I should take the sum of all x is equal to 1, 2, 3, 4, 5. So instead of adding all the probability values from 1 to 5, if you take the complement and subtract only the probability value of getting 6 here, so 6, then it is same as calculating the binomial distribution of all random variables from 1 to 5. So now here we have 1. Probability distribution of at x is equal to 6 will be 1 divided by 64. So 1 divided by 64, hence the value is 63 by 64. So this will be the binomial distribution of getting at most 5 successes. Next, 5 cards are drawn successively with replacement from a well-shuffled deck of 52 cards. What is the probability that all 5 cards are spade, only 3 cards are spade, none is a spade? So first, n is equal to, so that is number of trials is 5 cards. So therefore, I have to Take n is equal to 52. What is the probability of getting a spade here? So probability of getting spade, I will take it as 13 by 52. So when you cancel, it is 1 by 4. Why? Because we have only 13 spade cards out of 52 pack of cards. Then what will be Q? Q is not getting a spade card. That means 1 minus 1 by 4, whose value is 3 by 4. So hence here, a success will be 1 by 4, failure will be 3 by 4. Now, binomial distribution will be probability of x for value x is NCX, that is 5CX, Q to the power 5 minus x. So here Q is 3 by 4, 5 minus 6 into P to the power x, that is 1 by 4 to the power x. All 5 cards are spade. So that means probability value at x is equal to 5 is 5C5, 3 by 4, 5 minus 5, 1 by 4, 5. So 5C5 means 1. So this is into 1 into 1 by 4 whole power 5 is 1024. Hence the value is 1 divided by 1024. Next question is only 3 cards are spade. So that means we have probability at x is equal to 3. So we have 5C3, 3 by 4 whole to the power 5 minus 3, 1 by 4 whole to the power 3. So 5C3 is 10. Next here we have 5 minus 3, which is nothing but 2. 3 square is 9. 4 square is 16. Next here again we have 1 cube is 1. 4 cube is 64. And when you cancel it, the value is 90 divided by 1024, which can be written as 45 divided by 512 also. Next one is none is a spade. That means I need to take the value as x is equal to 0. So therefore, we have probability of x is equal to 0, which is equal to 5C0, 3 by 4, 5 minus 0, 1 by 4, 0. So 5C0 is nothing but 1. Next here we have 3 power 5 divided by 4 power 5. Anything to power 0 is 1 again. So multiplying this, we will get the value as 243 divided by 1024. So this is the value of the success rate where none of them are spade. Next question. The probability that a student is not a swimmer is 1 by 5. Find the probability that out of 5 students, at least 4 are swimmers and at most 3 are swimmers. Clearly, you can't take the value P as 1 by 5 here, because they have clearly said it is not a swimmer. When it is not a swimmer, they have given the failure value. That means they have given Q is equal to 1 by 5. Then what is P? P will be 1 minus Q, because they are complement to each other. So therefore it is 1 minus 1 by 5 will be 4 by 5. Hence the value of P is 4 by 5, value of Q is 1 by 5. Now we need to find the probability out of 5 students. So therefore we have 5 trials here. We need to find out at least 4 are swimmer. So at least 4 are swimmer means we need to find out the probability of x greater than or equal to 4. Next, at most 3 are swimmers means we need to find out the probability where at most 3 are swimmers. So we can take the value of x as less than or equal to 3 here. Now let us write the binomial distribution. Probability of x is equal to x here. N is 5CX. Q is 1 by 5 whole to the power 5 minus x. Next, P is 4 by 5 whole to the power x. Now here we have x greater than or equal to 4 means we have value for x is equal to 4 and value of x is equal to 5. We have 5C4, 1 by 5, 5 minus 4, 4 by 5, 4 plus 5C5, 1 by 5, 5 minus 5 and 4 by 5, 5. So, on solving this here we have 5C4 is 5 into 1 by 5 into 4 power 4, 5 power 4. So, 5 get cancels here. Next here we have 5C5 as 1. So, 1 into 1 into 4 power 5 divided by 5 power 5. On calculating, the value will be 2304 divided by 3125. So next we have the probability of at most 3-hour swimmers. So at most 3-hour swimmers means we have to take the probability value of x is equal to 0, probability of x is equal to 1 plus probability of x is equal to 2 and probability of x is equal to 3 here. So instead of taking the values as x is equal to 0, 1, 2, 3 here, I can subtract it as a complement of 1 minus probability of x is equal to 4 plus probability of x is equal to 5. Since we know this, probability of x is equal to 4 plus probability of x is equal to 5, we have got it as 2304 by 3125. I can take it as 1 minus 2304 divided by 3125. And when you solve this, you will get the value as 821 divided by 3125. So this is the binomial distribution for the at most 3-hour swimmers. So thus this is how we are going to calculate the binomial distribution for a Bernoulli's trials, where the number of success will be same in each trials, and by taking the probability of success and failure, we can substitute in the formula of binomial distribution and calculate the probability of a particular random variable. So this completes the chapter probability, and wish you good luck for your second PUC exam. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.